everyone, today our topic is energy and matter. Okay, so let's start. Energy stores. There are 7 types of energies. They are called energy stores. Let's look at the 7 energy stores now. 1. Kinetic energy store. Kinetic energy store is when anything that moves has energy in its kinetic energy store. 2. Elastic potential energy store. Anything stretched has energy in its elastic energy store. 3. Thermal energy store. Everything has some energy in its thermal energy store. The hotter something is, the higher its temperature. The hotter something is, the more energy in its thermal energy store. 4. Chemical energy store. Anything with energy which can be relieved by a chemical reaction is called chemical energy store. 5. Gravitational potential energy store. Anything in a gravitational field has energy in its gravitational potential energy store. 6. Magnetic energy stores. 2 magnets that attract or repel each other have energy in their magnetic energy store. 7. Electrostatic energy store. 2 electric charges that attract or repel each other have energy in their electrostatic energy store. These are the 7 stores of energy. Now let's look at energy transfer. There are 4 main ways to transfer energy. Let's look at the 4 main ways. 1. Mechanically. When a force makes something move. 2. By light and sound. When light or sound waves carry energy from one place to another. 3. Electrically. When electric charges move around on electric circuits due to potential difference. 4. By heating. When energy is transferred from hotter objects to colder objects. Here are the 4 main ways: mechanically, by light and sound, electrically, and by heating. Here is one example of how you can transfer mechanically. Just to remind you, mechanically means force to move an object. So here is kicking a football diagram. So the leg is the chemical energy store, and the ball is the kinetic energy store when it's being moved by the leg. Here is a diagram of which shows a train and then a broken bridge. So, as you can see, there were some sparks. Since the train wants to stop, there is friction. Friction is when the brakes are pulled when something stops. In this case, there are sparks coming because the train wants to stop. And friction does the work. There is thermal energy store and kinetic energy store in this. This is a diagram of which you can remember that friction is very useful in pulling in brakes and in movement. Now let's look at kinetic energy. How can we calculate kinetic energy using formula? Let's see the formula. EK is equal to half mv squared. Now let's look at the meaning of kinetic energy. Meaning, energy that is possesses due to its motion. The speed is faster. More kinetic energy is used. Mass is more. More kinetic energy is used. Let's see an question which we can find out and use the formula to. On the left-hand side, here is a particle. It is 0.1 grams. It travels 400 meters per second. Here is an airplane. It is 20 tons and travels 5 meters per second. The question is, which has the most kinetic energy this time? Let's work this out. Now let's work this out. So, let's use this formula to work this out. First, let's tell you what this formula means. Let's start from the left. E means energy. K means kinetic energy. Then is the equal signs. Then half. Half can be represented as 0.5 or half. You can use 0.5 because it will be much easier to times. Here is a times because it's not seen. So M means mass. Mass is always in kilograms. It will always be used in kilograms. Then V. V means velocity. That will always be in meters per second. Then there is the square sign. This is what each part of this formula means. Now let's work this out. So, we first need to convert 20 tons into kilograms and 0.1 grams to kilograms. So, 20 tons, we'll times it by 1,000, which will make it 20,000 kilograms. Now 0.1 gram. We need to divide 0.1 gram by 1,000. Then we will get 0.0001 kilogram. Now since both of them are kilograms, we can work this out. So, I've named them A and B. So A is the particle, B is the airplane. So, A, the particle. 0.5 times 0.0001 times 4,000 squared. For this calculation, we will get 800 joules. If we want it to be in kinetic joules, we will divide it by 1,000, so it will be 0.8 kilojoules, kinetic joules. Then it will be B, so B is the airplane. We will do 0.5 times 20,000 times 5 squared. We will get 250,000 joules. If we divide that by 1,000, we will get 250 kilojoules, kinetic joules. This is how we work this out.